Hi everybody, we are going to do some review on sections 4.1 to 4.3. So that was when we started talking about polynomials. So this first one, write a polynomial of least degree with roots -2 and -3i. So if we want to write a polynomial, we're going to start by thinking about what factors would have given these as roots or zeros. So it's going to be an equation, and so what would have given us that 0 would have been a factor of x plus 2. And what would have given this as a 0 is x plus 3i. But remember, conjugates are both 0. So complex conjugates are both 0. So if -3i is a 0 or a root, so is its conjugate, positive 3i. So we'd also have x minus 3i as a root. Okay, so then I'm going to multiply this out. So I'm going to start with these. I'm going to make a box. So this is going to be x plus 3i here, x minus 3i, this is x squared, 3ix, negative 3ix, and then negative 9i squared. Remember, I squared is equal to -1, so this is like having -9 times -1, or just 9. Okay, those cancel. So now I've got x plus 2 times x squared plus 9. Come on, pencil. Okay, and then we're going to make a box to multiply this other pair. So x plus 2 times x squared plus 9. So that's x cubed, 2x squared, 9x, and then 18. Oops, this should be y equals, right? So then we would have y equals x cubed plus 2x squared plus 9x plus 18. And that would be our polynomial. Okay, when it says least degree, that just means don't add extra stuff, right? You could have another polynomial that has these as roots and then also have other stuff like, I don't know, x minus 4 or x plus 2. When it says least degree, it means don't get any funny ideas. Just work with what you're given. All right, so for this next one, find the roots of this f of x equals x cubed plus 5x squared plus 8x plus 6. So for this one, we want to maybe try to factor it and see what we get if we factor it. So I know a lot of you guys like to use the Inspire for the factoring, and you could do that. I didn't bring one home, and off the top of my head, I don't know what that factors into. So what I would do is I would graph this, and I'm going to pause this and see if I can restart it, because I don't have my phone with me right now to look at the graph. All right, actually, why don't you guys, while I'm getting my phone, why don't you guys see what you get when you either factor that or graph it in decimals on your phone or on your calculator. Okay, there. So there is, I have the Decimals app. You don't have to download the app. You could just go to decimals.com. And so I'm going to enter that equation. So I'm going to enter y equals x to the third, and then plus 5x squared, and then plus 8x, and then plus 6. And you can't see that very well. Oh. There, now you can see it better, right? Alright, so the x-intercept there is -3, and that's really what I need from this, okay? So, I know I have an x-intercept at x equals -3. That means there was a factor that went with it, right? The factor would have been x plus 3. And so what I'm going to do is I'm going to think of this as, if I know one factor, I want to find, like, what's the other factor of this, so I could set it equal to 0. And so we had talked about doing synthetic division, right? So if I know the one factor, I can divide by that factor and then take whatever's left and then factor that or solve that. So if I'm my factor is x plus 3. It's in the form x minus r. It's the r that goes out here, so that would actually be negative 3. Then I'm going to put my coefficients across the top. Drop the 1, so this would be negative 3. Add is 2. Multiply is negative 6. Add, I get another 2. And then when I multiply, I get negative 6, and I add, and I get 0. Remember, this is my remainder. If something is a factor, when I'm dividing, the remainder should be 0. And it is, so I know I did that right. Okay, this had been an x cubed, so when I do my synthetic division, this is now x squared plus 2x plus 2. So if you had used your calculator to factor, it had told you this. Okay, so I know one solution is x equals negative 3. That's the same as my x-intercept. If I set this equal to 0, I get one solution of x equals negative 3. Okay, my other solution is going to come from setting my other factor equal to 0. And your calculator didn't factor it because it's not factorable. So what that means is we're going to have to use the quadratic formula. So, quadratic formula, opposite of b plus or minus square root of b squared minus 4ac all over 2a. So a is in front of the x squared, b is in front of the x, c is your constant. So I'm going to substitute those in. So opposite of 2 plus or minus 2 squared minus 4 times 1 times 2 all over 2 times 1. So 2 squared minus 8, that's the square root of negative 4. I'll come over here. So that's negative 2 plus or minus the square root of negative 4 is 2i, and then over 2. And then when we reduce this, remember we have to rethink of this as 2 divided by 2 plus or minus 2i divided by 2. Both things have to be divided by 2. So it's 1 plus or minus I. So our three solutions that we should expect, because it's cubic, are the negative 3 that I got from my graph, or you might have gotten when you factored, and then these two here, those conjugates. All right, so let's try another one. All right, this one, use the remainder theorem to find the remainder for this quotient. State whether the binomial is a factor. So we were just saying if something is a factor, that means the remainder is 0. So one thing you might be thinking is, oh, I could do synthetic division and find out what the remainder is. But this says the remainder theorem. The remainder theorem is that if you divide by something of the form x minus r, p of r is the remainder. So in this case, r is negative 6. So the remainder is what we get when we substitute negative 6 into our polynomial here for x. So if I do 4 times negative 6 cubed plus 2 times negative 6 squared plus 6 times negative 6 plus 1, that's going to be our remainder. So when we do that, we get negative 827, right? Since the remainder is not 0, x plus 6 is not a factor. All right, I got two more for you. Okay, so this one asks you to find the roots. Okay, so whenever I'm asked to find the roots or solve, we're trying to figure out what would make this polynomial equal 0. Okay, so the first thing you could do is you could, put it in your calculator and factor it, and it does end up factoring. If you, like I said, I forgot to bring my calculator home, so I'm going to go ahead and put this into decimals. I know when I'm first typing this in, there's a terrible glare. I'll move it up. Okay, so there's my graph. You can see it. There you go. I want the 0, so if you just tap where the x-intercepts are, it tells me I have one at 1, I have another at 0.5, and I have another at negative 1.5. Okay, so and it's cubic, and I should have 3, and there I have 3 real numbers, right? So I get x equals negative 1.5, x equals 1, and x equals 0.5. So if it's one that works out that way, and you can just put it in your calculator, or if you had factored it, it factored into x minus 1, 2x minus 1, and 2x plus 3, and then you could set each of these equal to 0 and get the same answers that way. Go ahead. That works. Just so you know, they're not all going to be that nice on the test, right? Some of them are going to be like the last one where you have to use the quadratic formula. All right, one more. Oh, your favorite. U-substitution. Okay, so when I look at this equation, I look at it and say, ugh, what's with all this business here, these cube roots of x plus 5? And so that's exactly what I'm going to let my u equal, the cube root of x plus 5. So wherever I see that cube root of x plus 5, I'm going to substitute in a u. I'm going to factor this. This is the easy factoring, right? When the coefficient here is 1, you need two numbers that multiply to be -4 and add to be positive, or -3. So -4 and 1. Right? Yes. Okay, so then I get u minus 4 equals 0 and u plus 1 equals 0. Okay, and then I'm going to put, and I could solve and get u is 4 and u is -1. And then once I do that, I'm going to substitute my u expression back in. And now I have to solve this. Which really isn't that bad. To undo the cube root, we're going to cube. So x plus 5 equals 64, and then take away the 5, so x is 59. And then here I'm going to cube, solve, whoops, just x plus 5. Equals -1, and then I'm going to subtract the 5, and I'm going to have x is -6. Okay, so those would be my two solutions. I hope everybody's doing well.